Welcome to Vaayusastra's research conference. So we have Priyanka SV and USG, and they are going to present on the topic industrial inspection robot. Priyanka and USG, you can
Uh,
start.
okay, sir.
Okay, sir.
So good morning, everyone. Myself, Priyanka, and my teammate is Yuvasri. Our project topic is industrial inspection robot. The main objective of our project is to develop an industrial inspection robot to detect real-time hazards and to monitor. And in our project, we are integrating gas sensors, flame sensors, and sound sensors to detect hazard gases, flames, and machinery defects respectively. And we are also using a ESP32 camera, which is used to provide live monitoring. And we are using GSM module for communication. Um the abstract of our project is it develops an industrial inspection robot for real-time hazard detection and safety monitoring. We are using Arduino as the controller, which integrates gas sensors, flame sensors, and sound sensors. And the ESP32 enables live monitoring, and the buzzer is to provide alert, and the GSM module is used for communication purposes. And in the literature survey, basically the first three authors are first A. Kumar, which was published in the year 2022. The title is A Review on Industrial Inspection Robot Challenges and Future Directions. In this, the methodology used is to analyze existing industrial inspection robots and their applications. And the second author is B. Lee. The title of the literature paper is Development of an Autonomous Inspection Robot for Power Plants, which was published in the year 2021. And the methodology implemented in this project is design and implementation of robot for autonomous inspection of power plants. And the third author is C. Zhang, AI powered visual inspection robot for manufacturing, smart manufacturing, which was published in the year 2020. And the methodology used in this is utilizes deep learning algorithms for visual inspection tasks in manufacturing environments. Uh, the next author is E. Silva, which was published in the year 2018, and the title of the project is Mobile Robot for Inspection and Maintenance of Wind Turbines. And the methodology implemented in this paper is it presents an robot designed for inspection and maintenance of wind turbines. It addresses the challenges of accessing and inspecting these structures. And the next author is Park. The title of this paper is Vision-Based Inspection Robot for Automated Manufacturing, which was published in the year 2015. And the methodology uses it employs and computer vision techniques for automated inspection of manufactured parts. And the last paper is proposed by I. Kim, and the title of this project is a mobile inspection robot for nuclear power plant, which was published in the year 2014. And the methodology used here is it presents an robot designed for inspection and maintenance tasks in nuclear power plants. It emphasizes safety and regulation and resistance. And the existence system will be explained by USG.
Okay, in the existing system, there is the manual inspection, which increases the labor cost, and it also will be the time consuming, high time consuming. In our project, we make it as possible, which reduces the labor cost and the less time consuming. There are multi-sensor integration in which we make it as the single product which has many sensor which also detects many many hazardous expressions in the proposed system. In our project, we we use the Arduino as the main controller, and we integrate gas sensor, flame sensor, and sound sensor. In the gas sensor, it will detect the hazardous gases, which in the gas it will detect the flames, which responsible for the explosions. Sound sensor, which will detect the high sounds which is produced by the machines. ESP32 cam is used for the real-time monitoring purpose. It is directly connected to the mobile phones through the Bluetooth module, which indicates the person that the explosions, the leakage of the gases like that. And the energy on harvesting system, we included that mechanism in our project to make the noise energy into the electrical energy, which gives the energy to the battery actually. Then next slide will be explained by the Priyanka.
Okay, basically the problem statement is actually the existing monitoring, they lack a real-time detection, remote surveillance, and automated mitigation mechanisms. Actually, the existing module includes only manual inspection, but in our project, we are making it as an virtual mode. Potential dangers for workers will be in the existing monitoring systems, and the block diagram includes already we explained a gas sensor, sound sensor, ESP32 cam, and flame sensor. All these are connected to the Arduino. The gas sensor detects hazardous gases, and the sound sensor detects unusual noises from the industries. And the ESP32 cam is used for live monitoring, and the flame sensor detects smoke, and all these are connected to Arduino. And in this project, we are using energy conversion. Sound energy is connected to the is converted into electrical energy, which is provided to the battery. The battery is rechargeable. We are using 12 volt 1.3 amps lead acid battery, which is rechargeable. And we are also using L29 3D motor driver. It is an 16 pin IC, which control two sets of DC motors, which can be moved in any directions. And it is an interface between two microprocessor robots and motors, which works in H-bridge concept. And GSM module is used for communication purposes, and a buzzer is used for sending alerts. The working principle, uh, I think I already
I have a
explained. Yes, sir. Yes, sir.
so how your robot, how it's going to be? It's like a rover or it's like a
No, sir.
humanoid?
Yes, sir. We'll operate through our the control is through our phone, sir. It contains four wheels, and it is an robot only, sir.
It is like
It is
Rover,
not
rover
a
only,
rover.
sir.
Eh,
rover. Okay. Have you guys done any prototype?
yes, sir. We are actually in the
Working
testing
through,
stage,
sir.
sir. We already connected our components, and we are testing our prototypes, sir.
Okay, continue.
Yes. Uh, the Okay, the novelty of our project includes energy harvesting mechanism. We are making use of industrial noises. Usually, the industries exhibits many noises. So we are converting those noises into electrical energy, and we are storing it in the battery to provide to provide energy to all the components. And this is our actual circuit. We are connecting Arduino Uno into the we are connecting sound, flame, gas sensors into Arduino Uno. And we are also using battery receiver. And in the right side of the circuit, we are having our robot, Bluetooth transmitter, and a battery unit. That battery unit is also rechargeable. uh, this is the circuit, sir.
So
And the
what
Yes, sir.
will be the response time and how far it can transmit the data
Sir,
and how far?
actually, we are uh, we are doing it in a small scale area for prototype. While implementing in the industries, we'll do it in large scale, sir.
Okay. So, for example, if any hazardous accident happens,
Yes, sir.
who the information, who will receive the information?
Sir, we are directly connecting into the buzzer, sir. So it will automatically detects. It will automatically alerts us, sir.
Alarm system.
Yes, sir.
Uh, on top, if it's connected to some like fire station or some
Yes, sir.
emergency government stations,
Yes, sir.
it will be a little more helpful. But
Yes, sir.
depends
We
on
will.
the
Okay, sir.
grade of the level of the accident.
Yes, sir. We will implement it, sir.
Okay.
Mm.
Continue.
Okay, sir. Uh, okay. The hazardous gases includes methane, ammonia, carbon monoxide, and we are detecting only flames, which is smoke, but we are not using a fire sensor because in all the industries they will have fire alarms. So we are using flame sensor because in the case of fire, only gases, sorry, smoke will only comes first. After that, only fire will come. So we are integrating flame sensor, and the safety is enhanced with the help of our project, and the labor cost is decreased. Accuracy is also increased, and we are also using real-time monitoring through ESP32 cam. And our tentative budget is as shown in the image, mm, which approximately is 3,500. Um, and the conclusion, this is an actually Arduino based robotic system which integrates multiple sensors, motor drivers, including L293D, and communication modules like GSM modules, and the sensors I already explained, gas, flame, and sound sensor, and ESP32 cam for live monitoring, L293D motor driver, and the GSM modules. That's it, sir.
Okay. Have you guys checked whether this kind of method exists any industries?
Yes, sir. Actually, already there are many existing modules, but they include only manual inspection, which is dangerous to all the workers working in the industry. But our project is fully automated. These are not in use, sir. And we are also using energy conversion concept in our project.
Got it. Okay.
Okay, sir.
Mm,
Any
okay.
doubts, sir?
So it's you guys have any uh, what is the stage? What stage is in your prototype is in what stage and how big it is?
Sir, it is actually in the size of a laptop. We are actually doing a prototype. We are under testing stage, sir.
Okay. So for the viewers, you can ask any questions if they have any questions or if they have any inputs. Which material did you guys use for the robot? Because to
Uh,
detect a fire thing or to
yes,
go
sir.
inside the fire, if your robot is stuck inside a hazardous place, it should withstand that hazard first. So, what
Yes, sir.
materials your guys are using, and how you are going to protect your emergency system, your robot?
Uh, Sir, actually, through alert messages, will automatically send it to every person who are working in the industries, and mm,
I asked about the material which is made.
one
What
minute,
material
sir.
your guys plan?
Um, Sir, I couldn't recall at the moment. I'll explain it, sir. 1 minute.
Maybe if you haven't done it, you can add that also as part of the
Okay, sir.
future work.
Okay,
So
sure,
your
sir.
robot has to be protected with a shield
Yes,
which
sir.
should withstand
Which
fire
withstand.
hazard, chemical
Okay, sir.
hazard.
Okay,
That will
sir.
be
Understood.
helpful. When, it,
Okay,
when
sir.
the prototypes become a product, so they
Yes,
will
sir.
see all these things. Accidentally,
Okay,
if
sir.
someone steps on it, it should not get
Okay,
crushed.
sir. Okay, sir. Sure, sir.
Yeah.
Okay,
So,
sir. Thank you.
if anyone have any questions, you can ask. You can address the audience, ask the audience.
Okay, if you have any queries, you can ask me now.
And if you guys have any inputs, that also you can give them.
Okay, sir. Thank
Okay. I guess there are no questions. Okay.
you.
Thank
Okay,
you.
thank you, sir.
Thank you, team.
Thank you.
Thank you, sir.